Hi everyone, welcome to another episode of Don't Be Average. In this video, I will show you step by step by an example how you can calculate a linear regression equation by hand from a set of data points. In our last video, I gave you this example of linear regression. Let's say you are working out and you want to lose weight. You are planning to put 4 hours into exercise every week. Won't you be interested to know how much weight you're supposed to lose by the end of the week? And how much you can lose if you increase your workout duration to, let's say, 10 hours a week? This is a simple example that you can solve using linear regression. Here, weight loss depends on how long you work out, and we are going to estimate this dependency using a linear regression model. Our dependent variable is weight loss, and it is dependent on physical exercise. Now let's recall the format of a simple linear regression equation. In this case, the regression equation will look like this. Weight loss equals A plus B times exercise. Our goal is to estimate the values of this A and B so that we can predict the weight loss for any amount of exercise. Only thing we will need is data, historical data. Let's say sometimes back you have recorded your workout durations and also recorded your body weight like I have shown here. We can call it training data. Now let me clarify one thing. Here it is not necessary that it has to be your own past workout data. It could be sourced or downloaded from somewhere else. However, since we are looking to predict your weight loss, it will be more accurate if the training data is your own or of somebody who is very similar to you. Now just to understand the data more, let's plot it. In this plot, in x-axis, we have exercise and in y-axis, we have corresponding weight loss. We can see this does not tell you everything. For example, if you want to know how much weight loss will happen at 10 hours of exercise per week, it does not have that information. That's where data science comes in. Data science tries to understand the pattern in the data so that it can predict the data points that are not currently present in the data. In this case, it is understanding the pattern using a regression line or the regression equation. And once you know it, you can see that the yellow marker is showing the estimated weight loss for 10 hours of exercise. This line is nothing but the regression equation weight loss equals A plus B times exercise, which means if we know A and B, we can draw a line like that and we can predict the weight loss for any possible point. Now we are going to estimate A and B. One question you may have that this is an equation and we are going to find the values of the two unknowns A and B. Then why is it called estimation rather than calling it solution? That's because we are not solving two equations for two unknowns here. We are using a data with multiple records and finding a pattern in that, which means the values of A and B will change based on what data we have used. And most importantly, if we use a bigger data set, there's a chance that we will get more closer to an accurate value of A and B. So we are actually estimating the values of A and B and trying to make it as accurate as possible. That is why it is not called a solution. It is called estimation. Now that our understanding is clear, let's start with the calculations. We have exercise X in one column and weight loss Y in another column. We have also added 3 more columns here, X square, Y square and XY. To fill in X square, we need to square our X values. To fill in Y square, we need to square our Y values. For XY column, we need to multiply the corresponding X and Y values. Now this is called a summation symbol. We are going to add everything up in all the columns one by one. Let's start by adding X values. If I add 3, 4, 1, 6, 12 and 8, I will get 35. Similarly, if I add my Y values 1, 1.5, 0, 1, 2, 5 and 4, I will get 14.5. Adding up my X square values will give me 271. Adding up Y squares will give me 49.25. And finally, adding up all the XYs, I will get 114. Now I am going to show the formula for A and B's estimation. This may look a little scary, but we have all the values that we need for this. In the last summation row, we have summation of x, summation of y, summation of x square, summation of y square, and summation of xy. One more thing that we need is the value of n. So n is the total number of observations. We have 7 records in the data. So in our case, n is equal to 7. Now let's estimate a first. Sum of y is 14.5. Sum of x square is 271. Sum of x is 35. And sum of xy is 114. That completes the numerator. In the denominator, sum of x square is 271. Sum of x's whole square is 35 square. If we calculate this expression, the value of a will be minus 0.09. And similarly, we calculate b, which is 0.43. Now let's write the linear regression equation. So that is how it will look like. If we try to write it in the form of weight loss and exercise, this is how it will look like. So weight loss equals minus 0.09 plus 0.43 into exercise hours. One observation comes from the value of A. A is slightly negative, which would imply that if you don't work out, you won't lose weight. And moreover, you may also gain a little weight. That's very interesting. Now you can predict weight loss for 10 hours of exercise. We can find that by just replacing exercise with the value 10. Now we are getting 4.21 kg, which means that if you work out for 10 hours a week, based on this data, you will lose 4.2 kg body weight. Now let's also look at the plot. In this plot, in x-axis, we have exercise hours. In y-axis, we have weight loss. All the blue dots are our training data points. And the blue line is the regression line, which is weight loss equals minus 0.09 plus 0.43 times exercise. So you can see this line is pretty close to all the points, which means that our regression equation is pretty accurate. And if you want to see the weight loss prediction at 10 hours of exercise, you will need to look at this orange point. And you can see that the point is located around 4.2 kgs of weight loss. This is how you can align your prediction with the visualization. That is how we can estimate the coefficients of a simple linear regression by hand. In our next video, I will show how you can quickly solve this linear regression problem using Excel. Thank you so much for watching. See you soon. Till then, take care and don't be average.
Everybody come here, gather round. Welcome to the freak show, the best in town. What the hell's wrong with me? I don't get along with anybody, honestly. I've been living in my own head constantly. Thoughts jumbled around, think I need a new lobotomy. Wait, all these thoughts are too negative. I don't wanna get lost in the sedative. Gotta show them what I got, I'm competitive. You know I'm about to go off, I won't let them win, I'll take